Alright, so this video is going to be about magnetic fields that are created by moving charges. So we've seen in class that if you have this positive charge and it's moving this way and it moves into a region that has a magnetic field like this, so remember that means that a dot means that the magnetic field is coming out of the page or the screen or whatever it is that you're looking at. Okay, the right-hand rule number 1, so that's going to be right-hand rule number 1, tells us that there's going to be a force on that charged particle. And if we do that, so if right-hand rule, thumb goes in the direction of the velocity that goes to the right, then your fingers should be pointing out of the board or out of the screen here, and that's going to make your palm face downward. So that means when the object comes inside this magnetic field, there is going to be a force that's going to be toward the bottom. Alright? Well, the question kind of becomes, why? Why is there a magnetic force on a moving charged particle? Why does the magnetic field rely on the charge, the magnetic field, but more importantly the fact that it is moving? Right? These two are both vectors there. Well, it boils down to this idea that moving charges create their own magnetic field. And this is what Oersted found whenever he was up in front of his class and he happened to turn on some current and there was a compass or something like it nearby and it started to deflect and he got all excited. And we saw this right before the break, that if you have this piece of cardboard or whatever and you have a wire come through it. Let me see if I can draw the wire coming in. So there's a hole right there, and so we have a wire that is coming through, just like that. And we have these compasses all lying around it, that when you turn the current on, okay, and the current is going in this way, right? So that means we're basically saying that we have the positive side of the battery right there, and it's going up like that. So the current is moving this way. Then what we find is that these compasses all point around the wire like this. And if you were to track it out, I'm going to do that in red. If we track it out, it looks like it's circling around that wire. So these moving charges moving through this wire are creating a magnetic field around it. Okay? And that magnetic field is traced out by the compasses, as we saw, and it goes around in a circle. And those compasses all point in a particular circle. So in a particular direction. So in this way, it's actually moving. If you're looking from above, it's going counterclockwise. Okay. Now the easiest way to remember this is using a secondary right-hand rule. So this is going to be right-hand rule number 2. Okay. This has to deal with fields around the wires. So imagine that you are grasping your wire with your right hand, and you're doing so that the thumb is pointed up like this. Alright? And what you're going to find is that your hand grasps around the wire in the direction that the magnetic field is curling. So if you're grasping the wire, then it's curling around the wire in that counterclockwise direction. So I hope you're doing this at home. You're grabbing the wire, or you're pretending like you're grabbing the wire, and you can see how your hand is curling around the wire in that counterclockwise direction. If we were to do the exact same thing, but have the current going in the opposite direction, so we have our hole here, and the current is coming downward, then now we have to turn our hand kind of upside down so our thumb is pointing downward, and what we'll see is that all of our compasses are now pointing in the opposite direction. And so they make a field that's going around the wire in a counterclockwise direction. So our magnetic field is counterclockwise. So this field is circling around the wire, and it is a circle. It's not a helix or anything like that. It doesn't follow the current down. It is, in fact, a circle, and the compasses prove that. So we just have this circle of magnetic field around the wire. this becomes a three-dimensional problem. You can see I'm having trouble kind of drawing the picture anyway. So if we happen to draw a wire going this way, where our current is going to the right, imagine pointing your thumb of your right hand to the right and envisioning the magnetic field going around a circle. Well, that circle is going to be, and I'm going to continue doing this in red, that circle is going to go around the wire, okay, and it's going to be going around the wire where up above it's coming out of the screen, while on below it's going into the screen. So this is a three-dimensional problem here. It's a three-dimensional picture where if you grab the wire with your right hand and go ahead and do that, then you're going to see that your fingertips are pointed out towards you, and that's above where the wire is. But if you curl it around, those fingertips would eventually go back in to the screen on the bottom side. So our magnetic field is all coming out of the page above the wire, and it's going into the page, or into the screen, below the wire. You can see each one of these basically traces out a circle, and that's going to get all really complicated really quickly. Each one of these would trace a circle going around this wire. Another way that we can draw this is putting the wire so that it is going into or out of the page itself, so we can really take a look at what the magnetic field is doing. So if we have a wire, and that wire is showing current coming out of the page, so here is current coming out of the page, then do this yourself. Use your right hand and put your thumb directed basically towards you. Right, it's coming out of the screen, it's pointing towards you who's watching this video, and you'll see that the current, your fingers curl around in a direction that looks like it's counterclockwise in this particular case. But if we had a wire where the current is going into the page, then that same magnetic field, again, try to point your thumb going straight into the screen here, then your fingers would curl around in this direction. So we have a clockwise direction over here, while we have a counterclockwise direction over here. So this idea of counterclockwise or clockwise is all going to depend on the method that you're using to try to visualize. Here, we don't really have counterclockwise or clockwise, we have into or out of the page, and we have to kind of visualize that it's a three-dimensional thing. While over here, we have counterclockwise and clockwise, but we have to visualize that the current is going into or out of the page. Now, we could have multiple wires set up right next to each other, and here's where things get a little complicated. So if we have one wire over here that is that's out of, so we have out of the page, we have another wire that is out of the page here, then we have a magnetic field, and again, try this out, right-hand rule. So which way does it circle around this? We have a, what is that, clockwise? Nope, counterclockwise, I got it wrong. So thumb going out. So we have magnetic fields that are doing this on both sides. Well, if you visualize a point right there in the middle, from the guy on the left, we have a magnetic field that's going up. From a guy on the right, we have, if you circle that around, we have a magnetic field that's going downward. So what do you think the magnetic field is right there at the center? Well, assuming these currents are exactly the same, the magnetic field would be exactly 0 right there at the center. Again, it's assuming the currents are the same. But on either side, they would actually be reinforcing each other. So over here on the left-hand side, we have both of them that are going to be going down. Over here on the right-hand side, we have both of them going up. I challenge you to use your right-hand rule and try to figure out whether that's right. So I'm going to leave you with this question. If we have a wire that has a current that's going like this, and remember, if the current is going to the right, then above the wire, we have magnetic field that's coming out of the page. and underneath we have a magnetic field that's going into the page, what would happen if we take that wire and we curl it around into a circle where the current is going around like that? I'll leave that to a question for the form below.